How we doing, guys? Today we're going to talk about seasons. Seasons definitely is something that can be a little confusing. And I'm going to show you a pattern with it because a lot of people think we're actually closest to the sun during the summertime, but that is far from the truth, all right? So I'm going to disprove that today. All right, so how do the Earth's motions affect the seasonal change? It's not just the Earth's motions, it's also the way the Earth is oriented, all right? So we'll get into that. So what allows us to go between these four seasons every year, and it is a pattern that happens. Okay, so what two motions are the Earth going through every day? Rotation, which is a spinning on the axis, and remember that's responsible for all the daily changes of the Earth. Another important fact is the Earth's axis is tilted at exactly 23.5 degrees. So you see in the diagram, you see it tilted over. So from vertical, that's 23.5 degrees to the side. And as a result, we get seasonal changes because of that. And as we change position in the orbit, that's the second thing that changes the season. So revolution, which is the orbital motion of the Earth around the sun, these two things together are what cause the seasonal changes. So rotation, just to give you a sense of what it means, spin in the axis. So think of a figure skater spinning in a circle, except the Earth is tilted on its side by 23.5 degrees. The Earth takes 23 hours, 56 minutes, and 4 seconds to complete one rotation. We know that a day is 24 hours. There are two things that actually correct this. Number one, the year isn't exactly 365 days, which I'm going to talk about in a moment. And then also this being shorter than a day, that's why we have leap years every 4 years to correct for that disparity in time. So that we round up to 24 hours, even though it's off by a little bit, and our leap year will fix that to make sure the time is actually synced correctly. The Earth rotates counterclockwise, which is opposite the clock. Another way to think of it from a side point of view is west to east. So whee! That's the way I like to think of it. And you can remember it in your mind that way. Okay, now, revolution, on the other hand, is also known as orbiting. And we orbit the sun every year. And it takes 365.26 days to revolve around the sun. That's 1 year for us. Again, that's why we have leap years. It's this fraction of being 0.26 more, and then the day being a little shorter. If we actually correct with the leap year every 4 years, the calendar will correctly stay in sync. All right, what causes seasons? Okay, so distance of Earth to the sun has nothing to do with the season. Okay, the seasons are caused by the tilt of the Earth on its axis, okay, and that's why all globes show that tilt, and the revolution of the Earth around the sun. And what's going to happen is the sun is going to target different areas on the globe during different times of the year, because as it orbits, a different part will be hit. And there is a clip, a movie clip that I will put up, which will explain this, but this is the general diagram here. So you can see summer. The reason why we have summer, we're actually furthest from the sun during our summer. It's the Northern Hemisphere is tilted towards the sun, and that's what makes it summertime. So that's summer solstice. And then it goes around counterclockwise to the next position. Now the tilt doesn't matter because it's not tilted towards or away from the sun. So that's fall, because that's after summer. And then we come around to the next position, and Northern Hemisphere is tilted away from the sun, so that's our winter solstice. And then we come back to the vernal equinox, which is also known as the spring equinox. Okay, how does seasonal change affect the Earth? All right, so summertime, we know the Northern Hemisphere is tilted towards the sun. We have more daylight hours, greater than 12 hours. There's more heat absorbed. It becomes hotter as a result. The sun is also stronger. You're starting to feel that each day now. The sun is actually getting stronger as it gets higher in the sky each day. Earth is actually further from the sun. So remember, we don't That's nothing to do with the seasonal change. And the first day is June 21st, all right where the end of the school year is. Okay, and again, the sunlight is targeting exactly 23.5 degrees or 23.5 degrees north on the first day of summer, all right, which is called the Tropic of Cancer, and that's where it comes from. The zodiac symbol for the end of June is Cancer. So that's how they name that line, and that's where the sunlight is directly hitting. And so that would be the strongest sunlight, and that's why the Northern Hemisphere is getting a stronger sunlight during that time of year. Okay, winter on the other hand is the exact foil opposite. So Northern Hemisphere is tilted away from the sun, less daylight hours, actually less than 12 hours. Less heat is absorbed, it becomes colder, the sunlight is indirect or weaker, the Earth is closer to the sun. So again, showing you that it has nothing to do with the seasonal change. Even though that's our cold time of the year, we're closer to the sun. And the first day of winter is December 21st, right before Christmas time. And lastly, spring and fall, which are exact foil opposite in terms of what type of season they are, but their characteristics are very similar. So both are around average temperatures. You can have warm and cold days, and you kind of go between the two. And there's average daylight hours around 12 hours, exactly on the equinox. The Earth is not tilted towards or away from the sun, so the tilt doesn't matter in that case. Okay, but it's still tilted. All right, even though these diagrams will show the tilt vertical, but it's just hitting the sunlight's hitting the side of the Earth where the tilt doesn't matter. So spring is March 21st on average, because this year it actually was the 19th. But in general, it fluctuates a little bit. Again, leap year kind of corrects this and then gets it back on track, but it will vary like a day or two from that date. And then fall, same thing, September 21st on average, and again, it can vary by a couple days. Okay, so the seasons, just be aware on the diagrams, they can reverse this order. This one shows summer on this side, winter on this side. They're always going to be opposite. Just look at the tilt of the Earth. So this is tilted away, this is tilted towards for the Northern Hemisphere, and the tilt doesn't matter on these. Just remember, we're going around counterclockwise in order. So summer, fall, winter, spring, summer. All right, so always go through that in your mind and trace through it and make sure you got the right order, because on the questions they could ask you what's the order of seasons. Here's another view. This is kind of like an up-front view showing you where the sun is hitting directly. So the first day of summer, June 21st, remember the direct rays or the strongest rays of the sun are hitting the Tropic of Cancer, 23.5 degrees north, which is the tilt of the Earth, and that's where that comes from. I mentioned that before. The next one, equinoxes, spring and fall. So September 21st, March 21st, the sunlight directly hits the equator. Results, 12 hours daylight, 12 hours darkness throughout the whole globe. And again, that's what makes the season very average, because the sun rays are hitting directly in the middle, so the sunlight is kind of spread out equally throughout the globe. And then lastly, winter. The sunlight is directly hitting the Tropic of Capricorn, 23.5 degrees south, and that's what makes our season, the cold season, so that's our winter time. And Capricorn is the zodiac symbol for December, so December 21st, the first day of winter. And so that's winter. And also, just a note, Southern Hemisphere, they're getting summer while we're getting winter. And if you go back to the previous diagram, when we're in spring, they're in fall. And if you go back to this diagram, the Southern Hemisphere is actually in winter while we are in summertime. So remember, Northern and Southern Hemisphere have exactly opposite seasons. And there is a little song which I'll put a link in the description. All right, I thank you guys for tuning in, and keep on working.